like us to look at number system. So once we talk about number system, we are talking about the system of counting. And counting is usually done in bundles. So to be a little bit more specific, let's look at the definition of number system. A number system, a number base is a system of counting in which certain units make up a bundle. So generally, counting is done in base 10. For instance, when you have 1 plus 1, the answer is usually 2. But if you have to do that calculation in another base, for instance, base 10, the answer will be equals to 10. 1 plus 1 will be equals to 10. So base 10 is sometimes called decimal or ordinary, while for base 2 is known as binary. This binary system is the system employed in computer system. So we have our base 8. Base 8 is known as octal. So base 16 is known as hexadecimal. Then we have various others. So let's look at bundles from base 10, base 9 to base 2. A close look at these bundles, you notice that for any particular base is always a digit less than the base. For instance, for base 10, we have just one short of 10 itself. For base 9, we have one number short of 9 itself. For base 8, base 7, base 6, 5, 4, 3, 2, we have just one number short of 2. So to avoid confusion when writing these bases, so it's always advisable to write it as, let's say for instance, I want to write 1 whole 3. It's advisable to write it down as 3 instead of 3 to avoid errors, because when you start solving, to avoid taking this 3, to avoid mistake errors like this due to maybe forgetfulness or maybe so to just avoid that error, as it's written as 3 like this, the chance of you making such mistake is less. So we can decide to, let's look at 1 or 2 examples we have here. So let's look at conversion from base 10 to any other base. So example 1, we have convert 124 base 10 to a number in base 8. We have to express 437 base 10 in base 5. Express 64 base 10 to base 6. So this is how you start solving. Have solution. One. 124 base 10 to a number in base 8. So you start dividing with 8. So 8 into 20, 8 into 12, 8 into 124, you have 15. The remainder of 4. 8 into 15, you have 1. The remainder of 7. 8 into 1, you have 0. Remainder 1. So take an arrow upward like this. Right, does 124 base 10 will be equal to 174 base 8. 1 the 1 first, which is 7, 4, 8. So let's move on to the second. Express 437 base 10 base 5. So repeat, draw a line. 437 5 into 43 will be 5 into 43 will give you 8. Remainder 3. 5 into 37 will give you 7. So you have 87. Remainder of 3. 5 into 87, you have 1 and 7. Remainder, oh sorry, you have 2 here. 2, not 3. Remainder 2. 5 into 17, you have 3. Remainder 2. 5 into 3, you have 0. Remainder 3. So don't forget to draw the arrow upward to indicate the direction you start picking your answers from. So move on, those 437 is 10 is equals to 3, 2, 2, 2 base 5. So let's move on to the third. Express 64 base 10 to base 6. 64 base 10 to base 6. So repeat, 64. 6 into 6, 1. 6 into 4, 0. Remainder 4. 6 into 10, you have 1. Remainder 4. 6 into 1, 0. Remainder 1. Draw your arrow upward to indicate the direction of your answer. So you have those 64 is 10 is equals to 1, 4, 4 big 6. So for best practices, it's advised to always write it out in words like this, 6, instead of in figures to avoid errors. So if you notice, we said this, they are written in bundles. For the first answers, a closer look at this, the conversion to base 8. See, we have 1, 7 and 4 here, and when we check this bundle here, 0, 1, we have 1, 7 and 4. So be always less the number short of 8. See this conversion to base 8. For base 5, same, we have 3, 2, 2. It's always a number short of 5. For base 6, likewise for base 6, same thing repeat itself. So that is how to do conversion from base 10 to any other base. That conversion from other bases to base 10. So the method we will employ is called is known as power expansion method. One thing you should know that is that this once you are converting from other bases to base 10, it's just the reversal of converting from base 10 to other bases. So reversal of converting to other bases convert to other bases. So let's pick an example to illustrate this power expansion method better. So example 1, let's use 1. We have 625 base 10, 625 base 7, base 7 rather, to base 10. So the power expansion method, so our 625 base 7 will be equals to 6 plus 2 plus and our 5. So since the base is 7, we multiply by 7, 7, 7. Whatever the base is, we will multiply by the base. If the base is 5, we will multiply by 5. So in this case, we have 7. So start from the last number. Start labeling 0, 1, 2. So move on, equals to, you have our 6 times 7 square is equals to 7 square is anything as saying 7 times 7 is equals to 49, or 49 plus 2 times 2 times 7, any number raised to 1, your answer will still result to that same number, and this number here is 7 plus 5 times 7 raised to 0. 5 times 7 raised to 0 is equals to 1. So according to the laws of indices, according to the law of indices, E raised to 0 is equals to 1. So no matter the number, once it's raised to 0, once it's raised to 0, you have 1. Even if it is 1 million, 1,000 raised to 0, you have 1. So let's move on. Let's cycle this out. So this is just an explanation. So we have 6 times 49, 49 times 6 times 9, 6 times 9, 54, so 4 take away 5, 6 times 4, 24 plus 5, that is 29, 294. So we have 294 here plus 2 times 7, that is 14. plus 5 times 1, 5. So if you are to add all together, let's say 294 plus 5, that is 299. 299 plus 14, that is 300 and the final answer is equal to 313 base 10. So let's proceed to the next example. Let's take example 2 1 1 0 1 0 1 base 10 to base 2 to base 10. So to proceed with this, let's say solution 1 1 0 1 0 1 is 2 is equals to 2. Let's write out each of the number 1 plus 1 plus 0 plus 1 plus 0 plus 1. So since the base is 2, let's start multiplying by 2, 2, 2, 2, 2, 2. So from the last base here, let's take it was 0, 1, 2, 3, 4, 5. So for 2 raised to the power of 5, 2 raised to the power of 5 is same thing as saying 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5. So 2 times 2 is equal to 4. 4 times 2, we have 8. 8 times 2, 16. 16 times 2, that is 32. So here we have equals to 1 times 32 plus 1 times 16 plus 1 times 8 plus 0 times 8 plus 1 times 4 plus 0 times 2 plus 1 times any number is equal to 0. Remember this 1. So 1 times 1. So let's just write 1 times 1. 32 plus 16 plus 0 plus 4 plus 0 plus 1. So 32 plus 16 plus 0 plus 4 plus 0 plus 1 is equals to 52. So it was 52 base 10. So let's take another example. For example 3. Convert 134 base 5 to base 10. Solution 134 base 5 is equals to 1 plus 3 plus 4. So let's multiply 5, 5 equals 0, 1, 2. So we have 1 times 25 plus 3 times 5 plus 4 times 1 is 25 plus 15 plus 4. So 25 plus 15 is equals to 40. 40 plus 4 plus 2, 44 base 10. So that is all for conversion from other bases to base 10. So let's look at conversion of a number in one base to a number in another base. So in this conversion, we first do what? We first convert the number from the base. Let's say for instance, we have a number in base 5. We first convert that particular number from base 5 to base 10. So once converted to base 10, then we convert to base 2, for instance, as our final base. So that is how that operates. Let's pick some examples. Let's start with 1. So convert 134 base 5 to base 2. So solution. In this case, we first convert 134 base 5. First convert to base 10. To base 10. So 134 base 5 is equals to 1 plus 3 plus 4 times 5 plus times 5 times 5 0 1 2 equals to 1 times 25 plus 3 times 5 raised by 1 is 5. So 3 times 5 is 15. 3 times 5 plus 4 times 5 raised by 0. Any number raised by 0 is 1. So we have 4 times 1. So we have 25 plus 15 plus 4. So our final answer here will be equals to 25 plus 15 plus 4 is equals to 44 base 10. So we now have it in base 10. But remember, we have to do what? Convert 134 base 5 to base 2. So we now revert to converting 44 base 10 into base 2. So we have 44 base 10. So we start 44 base 10. We now convert to base 2 finally. So like 2 into 44 is equals to 22. The remainder 0. 2 into 22. We have 11 remainder 0. 2 into 11. We have 5 remainder 1. So 2 into 5, we have 2 remainder 1. 2 into 2, 1 remainder 0. 2 into 1, we have 0 remainder 1. So we draw our arrow upward. So we start picking the answers from bottom. So 44 base 10 is equals to 1 0 1 1 0 0 base 2.
Head over to conversion of decimal number to base 10. So once dealing with decimal number, take note of the part after the point. So let's start 101.011 base 2 is equals to about 1 times 2 plus 0 times 2 plus 1 times 2 plus 0 times 2 plus 1 times 2 plus 1 times 2. So in this scenario, we are going to divide this into two parts, two separate parts. So we start labeling from the first part. The part of the whole number is 0, 1, 2. So from this part, from this, you have minus 1. Since the negative part, minus 1, you have minus 2 and minus 3. So we move on to equals to 1 times 2 raised to the power of 2 is 4 plus 0 times 2 plus 1 times 2 raised to the power of 0 is 1. So we have plus 0 times 2 raised to the power of minus 1 is in here saying 1 over 2 plus 1 times 2 raised to the power of minus 2 is in here saying 1 number 2 raised to the power of 2 is 2 raised to the power of 2. 1 over 4, let's say 1 over 4, let's go straight forward, plus 1 times 1 over 2 raised to the power of 3 is equals to 8, so 1 over 8. Let's proceed to 1 times 4 is 4, 4 plus 0 plus 1 plus 0 times 1 over 2, 0 plus 1 over 4 plus 1 over 8. So here we have, so we can easily write it, make all of them a fraction. So here we have our LCM to be equals to 8. So here we have 8 divided by 1, 8 times 4, 32 plus 0 here, since it's 0, you have 0 back, plus 8 times 1, 8 plus 0, 8 divided by 4, 2, 2 times 1, 2, plus 8 divided by 8, 1, you have 1 here. So let's proceed. 32 plus 8 plus 2, 32 plus 8, 40 plus 2, 42 plus 1, 43 over 8, 43 over 8. So 43 over 8, 8 into 40, we have 5 whole number, 3 over 8, or 5.375 is 10. So let's pick this for convenience. So 101.011 base 2 is equals to 5.375 base 10. And proceed to the next part, which is conversion of fraction of decimal numbers in base 10 to base 2. So let's pick this example. So solution. So for this part, we are going to split into two. We'll deal with the whole number part and the fraction part separately. So let's go. We have 9 base 10 is equals to 9 is 2. 2 into 9, we have 4 remainder 1. 2 into 4, 2 remainder 0. 2 into 2, 1 remainder 0. 2 into 1, 0 remainder 1. So that is, let's take our arrow upward. 9 base 10 is equals to 1 0 0 1 base 2. So the fraction part, 7 over 8. This is how we do this part. Over 8. Then we split the 7 into multiples of, let's just say, let's see it as 2 raised to the power of 0 plus 2 raised to the power of 1 plus 2 raised to the power of 2. That is 4 plus 2 plus 1 over 8. So at the end, we still have our 7 over 8. When we add 4 plus 2 plus 1, 7 over 8 over 8. So just a way of splitting it up, but we are still doing the same thing. So let's proceed. Four over 8. Let's split it up. 2 over 8 plus 1 over 8. So equals 1 over 2 plus 1 over 4 plus 1 over 8. From here, let's proceed. 12 equals to 1 times 2 raised to the power of minus 1 plus 1 times 2 raised to the power of minus 2 plus 1 times 2 raised to the power of minus 3. If you on a closer look, you notice we have here 1, we have here 1, we have here 1. So let's pick it up. We have 1, 1, 1. So 7 over 8 part is equals to 0.111 base 2. So let's add it up with this. We have 9 over 7 over 8 base 10 is equals to 1001 base 2 plus 111 base 2 is equals to 1001 and 111 base 2. So that is all.